Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC B12F3 indicates that there is a communication issue between the power control unit, PCU, often identified as the body control module, BCM, and the transmission control unit, TCU. The PCU plays a critical role in managing various electrical functions in the vehicle, whereas the TCU is responsible for controlling the transmission's operation. When this code appears, it suggests that the PCU cannot establish or maintain communication with the TCU. This could lead to issues in transmission operation and overall vehicle performance. Effective diagnosis and troubleshooting are essential to ensure proper vehicle functionality. By following the systematic steps outlined in this troubleshooting guide, technicians can identify and rectify the source of the communication failure, ensuring that the vehicle returns to optimal operating conditions. The error code B12F3 points to a lost communication issue between the power control unit, also known as the body control module, and the transmission control unit. The power control unit is typically located under the dashboard or inside the central control area of the vehicle, depending on the specific design of the Honda Accord model. Its primary function includes managing various electrical signals throughout the vehicle, including those related to the transmission's performance. On the other hand, the transmission control unit operates the transmission, determining the best shift points for efficient power delivery to the wheels. Any communication breakdown between these two components can create significant issues, including inability to shift, poor acceleration, or complete power loss. Identifying the exact location of these components is crucial for effective troubleshooting. Several factors can contribute to the DTC B12F3. Firstly, faulty wiring between the power control unit and the transmission control unit is a common cause. Damaged wires can lead to loss of communication, causing malfunction in the system. Secondly, poor or loose connections between these components can prevent proper electrical signals from being transmitted, leading to intermittent issues or complete failure. Lastly, a malfunctioning component, whether it's the PCU or the TCU itself, can be at fault. In cases where the components are not responding correctly due to internal failures, the communication link can be lost. Thoroughly inspecting these factors is vital to pinpointing the source of the problem and effectively repairing it. Drivers may experience several symptoms associated with DTC B12F3. The most immediate indication is typically a warning from the check engine light, alerting the driver to potential issues. In addition, transmission performance might be noticeably affected. For instance, the vehicle may hesitate during shifting or may not shift at all. Drivers may also notice irregular behavior in other electrical systems, such as windows or lights, if these functions are affected by the same body control module. These symptoms are significant indicators that warrant further investigation into the communication links between the BC and TCU. Understanding these symptoms will help technicians prioritize their diagnostic approaches. The first step in troubleshooting DTC B12F3 involves utilizing the Honda Diagnostic System, HDS, to clear any existing DTCs. This step is crucial as it establishes a baseline for the system's current state. After clearing the codes, you will need to cycle the vehicle through various modes, specifically the off, lock, accessory, and on modes, 10 times. This action helps to reset the system and can often resolve intermittent faults. After completing these cycles, check the system for DTCs once more using the HDS. If DTC B12F3 appears again, it's an indication that further investigation is required, proceeding to the next step. However, if it does not, the problem may be transient, possibly due to a loose connection. In this step, begin by ensuring the vehicle is in the off-lock mode. Disconnect TCM connector A23P, which houses critical wiring connections between the TCU and the PCU. After disconnection, measure the voltage between designated test points. The test points are TCM connector A23P, number 15, number 23, and number 8, each compared to a body ground. Conduct these tests under the condition that the vehicle is off. Confirming the presence of battery voltage at these points indicates that the primary wiring for TCU connections is intact, thus allowing you to proceed to check further potential faults. If battery voltage is absent, this indicates an open circuit or high resistance in the wires, which will require immediate repair. For troubleshooting step 3, transition the vehicle to the on mode. With TCM connector A23P still disconnected, you're tasked with measuring the voltage at test point number 6 against a body ground. It's important that the vehicle is in the on mode for this test. If battery voltage is detected at this point, it confirms that the IG1 TCU wire is functioning correctly, allowing you to move on to the next set of checks. Conversely, if no voltage is present, it suggests either an open circuit or high resistance in the IG1 TCU wiring, necessitating repairs to restore continuity and proper functionality. In this fourth step, ensure that your vehicle is switched to the off-lock mode again. With TCM connector A23P disconnected, check the continuity between designated test points within the connector. Specifically, these are TCM connector A23P, number 1 and number 9 against body ground. Conducting this continuity test under the specified vehicle condition is critical. If connectivity is confirmed, this means that the LG1 and LG2 wires are functioning correctly, allowing progression to the next troubleshooting phase. If continuity does not exist, however, this suggests that there may be an open circuit or poor connection, particularly with the ground wire, G303, requiring immediate attention to ensure a secure ground connection. For this step, first disconnect the body control module connector C66P to ensure safety and accuracy in testing. With both TCM connector A23P and body control module connector C66P disconnected, you will now check for continuity between TCM connector A23P, number 17, and body ground under the vehicle's off-lock condition. This step accurately tests the integrity of the IGN TRX wire. If continuity is detected, it indicates that there is no short circuit to ground in the wire, indicating it is functioning properly. If continuity is absent, though, this points to a potential short circuit, and necessary repairs must be addressed to rectify the wiring issue before proceeding further in the diagnostic process. Continuing into troubleshooting step 6. This part of the process requires checking for continuity between the IGN TRX wire in body control module connector C66P, number 35, and TCM connector A23P, number 17. Ensure that both the TCM and the body control module are still disconnected and that the vehicle is in the off-lock mode. Finding continuity here indicates that the wire is functional and intact, suggesting no open circuits present in this section of the wiring. Conversely, if no continuity is found, this signals an open or high resistance in the wiring. In this case, immediate repairs would be necessary to secure a reliable electrical signal and ensure that communication between the modules can resume. Step 7 involves reconnecting TCM connector A23P and body control module connector C66P after completing the previous checks. With these connectors reattached, ensure the driver's power window is open before placing the vehicle into the off-lock mode. Start by disconnecting the vehicle's 12-volt battery terminal and allowing a wait of at least 10 seconds for the system reset. After waiting, reconnect the battery terminal. Now, transition the vehicle to the on mode before moving it back to the off-lock position. The next critical step is to test the keyless access system. Hold all keyless remotes outside the open driver's window while pressing the Start-Stop button. Ensure all doors are closed during this test. If successful, it means the system works as expected, and the communication issue may have been resolved, allowing the process to continue to the final step. However, if the mode does not change, replacing the body control module may be necessary. In the final troubleshooting phase, repeat the initial steps by clearing the DTCs again using the HDS tool. This is designed to refresh the system state one last time. Similar to earlier, you will cycle through the vehicle modes: off, lock, accessory, on, and back to off, lock, 10 times. This uniform cycling ensures that the vehicle systems recalibrate and allows any intermittent faults to become apparent. Following this procedure, it is crucial to check once more using the HDS to see if the B12F3 DTC is still indicated. If the code reoccurs, it indicates a potential failure in the transmission control module itself, which may require replacement. If the code does not appear and no issues are observed, it is likely that the previous communication issues were transient, warranting a check for any loose or poor connections that may still exist. The final verification step involves double-checking the diagnostic status after completing all troubleshooting steps. It is essential to clear any residual DTCs and ensure that DTC B12F3 has not returned. Further testing should involve driving the vehicle and verifying that all previously affected functions, especially those related to the transmission and the electrical system, are operating correctly. This could involve checking transmission responsiveness during gear shifts, as well as ensuring that all electrical functions managed by the body control module are working as intended. If all checks confirm satisfactory operation, the repairs can be documented, assuring both the technician and the vehicle owner that the issue has been resolved effectively. Implementing preventive maintenance is key to minimizing the likelihood of DTC B12F3 reoccurring. Regular inspections of the vehicle's wiring and connections can significantly mitigate communication issues between the power control unit and transmission control unit. During routine service intervals, it's advisable to inspect connectors for signs of wear or corrosion, which may impede electrical flow. Keeping the electrical systems monitored, especially after any automotive repairs, is also beneficial. Additionally, ensuring that software updates for the body control module and other vehicle electronics are applied can enhance system reliability and reduce the chances of communication errors. By adhering to these preventive practices, you can help maintain consistent vehicle performance and safety. In summary, DTC B12F3 is indicative of lost communication between the power control unit and transmission control unit. The structured troubleshooting guide outlined various systematic steps, each designed to identify potential issues, ranging from faulty wiring to module replacements. Establishing reliable electrical connections between these units is paramount, as it ensures the vehicle operates smoothly without unexpected transmission issues. The insights gained throughout this troubleshooting process underscore the importance of preventive maintenance. Regular inspections and monitoring can significantly diminish the risk of future electrical communication failures, helping maintain vehicle performance and ensuring driver safety. Ultimately, staying proactive and informed equips technicians and vehicle owners alike with the tools necessary for effective vehicle care. Please like and subscribe to the channel. See you next time.